All right, hello, folks. I can't wait to meet you in person, but this is the best I got until after softball. I guess I get to meet you in person on June 4th. So we're going to talk about data analysis, probability, and discrete mathematics here. So we'll start with data analysis, and these are places that kids always have problems with, no matter what level. Even if they could, I'm sure they've been taught as they come to the high school, and some of them still don't get it. So mean, just to show you what I would do if I was teaching this, is I would say mean is the average. So every time you hear average, I would say mean. I would also have the kids repeat it over and over and over again out loud. A choral response here, and so so they get mean and average, and if they chorally respond, research shows most of the kids retain it. Median is also the middle. All right, is the middle of the data, right in the middle. We'll talk about that in a minute. And the mode is which number or numbers occur the most. I think you all know that. So let's give an example of the mean here. All right, so we'll start with mean. Go a different color here. So the mean, and by the way, what I'm doing here is I'm using a program called Screencast-O-Matic. I have a tablet that I'm writing on, and the software here is the Smartboard software. I like to flip my classrooms a lot. And what I mean by flipping the classroom is I mean having them go home on YouTube, watch a video, watch the content of the video, and in class enhance what they learned. So also teaching you another strategy here. So the mean, if you ask the kids, maybe if you want to ask them their favorite numbers, you want to ask them how old they are. I would start out with two kids, and you get the concept of mean. You can practice that. I would practice it with real numbers, doing it with them, asking them perhaps their ages, and if two people are 7 years old, I'm going to show them this formula, and I'm going to say, you add them up and divide by how many there are. Well, the two numbers given were 7 and 7, so I add them up. I get 14 divided by 2, which is 7. You might say, well, this is looking a little different than maybe what you've taught it, because now you can answer and ask higher level questions. For example, now I have two numbers that average 7. All right, can you think of and one of the things you could ask your students, can you think of two other numbers that can average 7? So let them play around with the two numbers that are there, so you can come up with a lot of different unique situations where they average 7. You might get into some decimals, who knows? So I would do that for a little while, and then I would say something like this. Well, now I have an average of 7. I said, well, if we add another one in here, okay, and we divide by 3 now because we added another piece of data, I want my average to raise to 8. So maybe some of the kids will notice, well, what divided by 3 is 8? Well, or you could multiply them and do the inverse operation. So we can say 7 plus something else has to equal 24. And I would also say, what divided by 3 gives me 8? They may say 24. So at that point, you know that this was 14. We have to add 10 more. And that's the kind of grade you would need to get an average of 24. These are the type of questions that are on HSPA questions. I know that's going away, but your asks have this all the time. Okay, especially your Ask 7s and Ask 6. So this is one way to do it. I mean, you could do it from an algebraic standpoint, depending on the level and what ask you're doing, and you can do it from an algebraic standpoint. All right, and say this is 7 plus x equals 24, doing your inverse operations, multiplying this by 3 and then multiplying this by 3. This gets rid of fractions. So that's where I would get 14 plus x equals 24. And I find teaching you guys, I actually teach by example. So as far as algebra is concerned, what I usually do is draw a line down there. I want variables on one side, numbers on the other side, and we just move across the border. So that's some work with the mean. Now the median is a little different. We'll go green for median here. All right. The median is the one that is the exact middle of the data. So if I give, for example, they have to also, in median, they have to be in order. You need your numbers in order. So now, 3, 4, 5. The middle of the data is 4, so that would be the median. Notice, there's 3 terms here. There's an odd number of terms. So when there's an odd number of terms, this is important. When there's an odd number of terms, it becomes one of the pieces of data. It becomes that 4. Watch what happens when there's an even number of pieces of data. 3, 4, 5, 6. Now the middle is, if I break these up, there's 2 here and 2 here. And maybe you want to show that. Okay, maybe you want to show them separating, even with, I crumble pieces of paper up sometimes, little pieces of paper. So I get them to the sides and say, you know what? What's the middle? Well, in the middle would be 4 plus 5 divided by 2. That is 9 divided by 2, which is 4.5. When there's an even number, this was 4 terms. When there's an even number of pieces of data, you're going to have to take the average of 2. You're going to have to take the average of 2. So I would have students, I would randomly pass out some cards with some numbers to begin this class, perhaps. I would have kids put them in order. Okay, that could be a task right there in itself. I could have, once they put them in order, we could start splitting them up and say, where's the median? Where's the middle? The last one in our data analysis, in our data analysis is going to be, here I'll separate it nicely, okay, and the last thing in our data analysis is going to be the mode, and the mode is the one, it's easy, the one that recurs the most. Easy to teach because M-O, M-O, they both sound the same. Mode, most. That's how usually kids get it. So now if I have 3, 4, 5, 6, and I ask the students, well, which one occurs the most? And you're going to get a lot of different answers. None of them occur the most. They all occur the same amount of times. So if they all occur the same amount of times, we say that there's no mode at all. All occur same amount of times. Now, what if 1, 3, 4, 4, 5, 6? Obvious. What about if I add another 6? Well, which one occurs the most? Well, 3 occurs once, and this is where you get into frequencies. Okay? 3 occurs once, 4 occurs twice, 5 occurs once, 6 occurs twice. And especially if you pass these cards out as they walk into the room, you can get them together and have them count. And you see, well, these two definitely occur more times than everybody else. So the mode is 4 and 5 and 6. And of course, the general one would be 3, 3, 4, 5, and then 3 would be the mode. I might start with this one, okay, and work my way up and ask the students to give you the answers. What's the mode here? You're going to engage in some really good conversations, hopefully, with the students and see where their thinking lies. Where's the mode here? So it's important that the word most has to happen. All right, one of the greatest things about this program is that was my phone, so I could pause it and then pick up right where you left off. So the only thing about it is that it can only go about 15 minutes. So I'm going to have to post a few of them. All right. So mode's the most, median, and the mean. Okay, and that's data. That's one of the things of data analysis. Another thing with data analysis, if I may, is the connection between with bar graphs, circle graphs, they always ask questions on graph interpretations. So if you look at a bar graph, all right, I think you all know how to read a bar graph. But if we look at a bar graph, you could have students, I don't know if you know this, but in every newspaper, there is some type of graph in every newspaper, especially the USA Today. So you could have them go online, look at a graph, interpret some graphs, and this could be one of the things they have to know is to make sure that you have a good scale. All right, that's where most of the students make mistakes, is the reading of the scale here. All right, sometimes the scale is not so nice. Sometimes it is. So take a look at your graphs. That's another thing that we could talk about when I get there. But that's data analysis. So if you have any questions, I can't really answer them because I'm virtually away from you, but I would like to do something with probability next. So look for the next video on probability.